Pleasant day to everyone. Today we're going to discuss Module 5 of the subject CE 3151. In this topic, we're going to discuss roots of nonlinear equations. So as engineers or future engineers, we would now apply mathematical models in the field of science and engineering, in which this will now involve solving equations. And these equations would now involve one or more variables, which can be written as f of x, or the function of x, equal to 0, or the function of x and y equal to 0. Such equations now can be written in the form of linear and nonlinear equations. So what is now the difference between linear and nonlinear equations? So when we say linear equations, this would now be equations that would represent a straight line. So when we plot values of our variables into a graph, would now be forming or resulting in a straight line. While for nonlinear equations, this would now represent equations of a curve. So when you plot this on a graph, we will be forming different forms of curve. So for linear equations, the degree of the equation will always be equal to 1. And for nonlinear, its degree will be 2 or more. So for linear equations, as we plot our variables into our graph, the lines formed now can be extended in any direction in our straight line or straight form. While for nonlinear equations, increasing the degree of our equation would also increase the curvature of our curve or of our graph. The general equation for our linear equation would basically follow y is equal to mx plus c, which is basically the equation for a slope of a line, wherein y and x are our variables, m is the slope of our line, and c is a constant value. For nonlinear equations, its general equation will follow ax squared plus by squared equal to c. Or it could follow ax raised to n plus by raised to n minus 1, and so on. Okay, so for linear equations, your x and y are our variables. A, B, and C are constant values or coefficient values of our variables. Examples of linear equations would include now 10, x equal to 1. So as you can see, x here is 1 degree. We have 9y plus x plus 2 equal to 0. So y and x are also in the first degree. We have two variables in 1 degree. Then we have 4y equal to 3x. We have 99x plus 12 equal to 23y. All of these are examples of linear equations. For nonlinear equations, example of this would include x squared plus y squared equal to 1. This follows our general equation. We also have x squared plus 12xy plus y squared. So we have two equations or two variables in our equation, and one or more of our variables are in the second degree. Meron man tayong 1 degree, pero yung maximum degree natin is more than 1. So it is now under a nonlinear equation. Another example would include x squared plus x plus 2 equal to 25. So single variable, pero maximum degree of one variable or one term is in or is more than 2. So it's under nonlinear equation. So for nonlinear equations, there would be several categories. The first one is what we call your polynomial equations, which is defined according to Merriam-Webster, a mathematical expression of one or more algebraic terms which is raised to a non-negative integral power. It means that our terms would be raised to positive integers. Okay? And also, this would include fractions as well. So examples we have for quadratic equation, we have function of x is equal to ax squared plus bx plus c equal to 0. We have our cubic equation, function of x is equal to ax cubed plus b x squared plus cx plus d equal to 0. We also have another example of polynomial equation, which is our linear equation, which is a first degree order polynomial. So yung x plus b or ex equal plus b equal to 0. So take note that for linear equations, it may be a polynomial equation, but it will not be under nonlinear equations. Therefore, we could say that for polynomial equations having degrees of more than 1, meaning 2 and above degree, will be considered non-linear. Okay? So other categories would also include transcendental equations, or what we call non-polynomial equations. So this would now be defined as an equation that would involve trigonometric functions, logarithmic functions, exponentials, and others. For any other equations that would have in exponential form pero or it's raised to a certain number pero hindi siya whole number. So it's a negative power or a fraction na power. So your radical values. Okay? So polynomials dapat raised to positive values and our power should be whole numbers. So pag ito, for example, ax raised to 2/3, then it is not a polynomial equation anymore, but instead considered a non-polynomial equation. So examples of your transcendental or non-polynomials will be tangent of x minus e raised to x. So it involves trigonometric functions. So sine x minus x e raised to 2x equal to 0. E raised to x logarithmic function is equal to cosine x. 2x equal to x squared. 2 raised to x is equal to x squared is an example of non-polynomial equation. So the solutions now for one variable equations would now be called the root of equation or the zero of the equation. So when we say one variable, so isa lang yung unknowns natin. So any degree as long as it is one variable. So in solving now this kind of equations, the solutions is called the root or the zero of the equation. The root now of the equation is defined as a numerical value of x that would satisfy our given equation. So for solutions of our linear equation, nonlinear equations, graphically, we could see here or identify now the number of our solutions or the roots for our equations. So for linear equations, linear functions, we have 1 degree. So we have several solutions for this. We have quadratic function. So it means we have at this point, it is an equation with one solution. For cubic function, we have 1, 2, 3 solutions. For quadratic or quartic function, we have 1, 2, 3, 4. We have more than one solution, so first, so quintic and so on. Meaning, one solution for quadratic function, we could have one solution for values of x. We could have x1 equal to x2, or it could also give us x1 and x2. So basically, for our graphs, it would show us that we have two the number of our solutions. So for quadratic function, there's also a possibility wherein when we graph it, we have now this graph. So we have x1 and x2. Okay. That's for our solutions by graph. So there are different methods in finding roots of nonlinear equations through numerical methods. The first one is what we call the incremental search. We also have the bracketing methods, and under which this will include bisection method, false position method, and then we have your open methods, which will include the fixed point iteration method, and the Newton-Raphson method, and lastly, the second method, all of which we'll be discussing for the entire module 5. So for the first method of finding roots, incremental search, this is now a numerical method that is used to find the interval of two values of our x where at least one root is located. So given now function of x, given a value of x such that the function of x is equal to 0, what we'll do is to start a guess or an initial guess, which is x sub o, until a final value x sub 1, which will now define the lower and upper limits of our interval respectively. And in here, we are going to use a constant increment or change, which we will call delta. So in here, we'll have now the increment constant to be added to our initial guess to get the final value x1. And this equation now can be converted into an iterative equation since we want to get multiple values of x that could possibly satisfy the given equation or function of x equal to 0. And this will now become x sub n equal to xn minus 1 plus delta x. So, ina-add natin yung increments natin, yung delta x, to our newly identified value of x. And from these values of x, we can now solve a series of x, and from here, we'll be able to evaluate now the equation for the function of x. And if the sign of fx changes as we substitute the values of x in our iterations, so if it changes, or if fxn now is less than 0, then the roots would exist between xn minus 1 and xn. Okay? Or if the function of xn minus 1 fxn is greater than 0, then it means that there is no root between the two values. So in incremental search, we have to look for the value of x that will give us or satisfy us with the function of x equal to 0, or meron tayong change in sign between our values of x, or incremental values of x. Okay? So if that's the case, the root now can be estimated as x of n minus 1 plus xn divided by 2. Okay? So to understand incremental search, let us solve an. So we have example number 1. Find the root of the equation f of x is equal to 2x squared minus 3x minus 5 equal to 0. So basically, we could solve this simply by our factorization or by quadratic equation. But since our subject is numerical methods, we'll be applying now incremental search. Okay, so in here we're going to use a lower limit -3 to an upper limit of 3, positive 3, and use an increment of 0.5. Okay, so by solution, xn now, so we have our x sub o from our lower limit, and from there we substitute it in our equation, so we'll have the function of x for the given x sub n. So our first x is -3, so we just substitute 3 in our equation. So substituting, we'll get now f of the function for x equal to -3 is now equal to 2 times -3 squared minus 3 times -3 minus 5 is equal to 0, or f of -3 is equal to 18 plus 9 minus 5, or that is now equal to 22. Okay. So next, we move on to increment of 0.5. So -3, next will be -2.5. So just substitute this value in our equation. So substituting, we get the f for -2.5 is now equal to 2 times -2.5 squared minus 3 times -2.5. It's minus 5 equal to 0, or that is now equal to 15. So next, -2.5, -2.5 plus 0.5. So our new x is, so x2 is now equal to 2. So substitute now f of x sub 2, which is -2.0, is now equal to 2 times -2 squared minus 3 times -2 minus 5 equal to 0, or that is now equal to 9. So next, x sub 3 is now equal to, previous is -2, so plus the increment 0.5. So substitute the value f of x3 is equal to -1.5. Substituting, we'll get 2 times -1.5 squared minus 3 times 1.5 minus 5 equal to 0, or f of -1.5 will give us 4. Then we get x sub 4 is equal to -1.5 plus 0.5, that will give us 1. So substitute it, x is equal to -1. So 2 times -1 squared minus 3 times -1 minus 5 is now equal to 0. Okay, so we have achieved now 0. So therefore, following function of x equal to 0, -1 is a root of our equation. Okay, so that is only one of our roots for the given equation. So what we will do is to continue our incremental search. So from 1, we move on to, so negative 1 is 0. So we follow negative 1 plus 0.5 will give us negative 0.5. So you substitute this 0.5 in our equation. 2 times negative 0.5 squared minus 3 times negative 0.5 minus 5 will give us now a value of negative 3. So next, negative 0.5 plus 0.5 is 0. So f of 0 is equal to negative 5. Next increment is 0.5, which will give us negative 6. Then we have 1, which is negative 6 as well. So we continue to until 3. So we have 1, negative 6, 1.5, negative 5, 2, negative 3, 2.5, 0, and 3 is 4. So as you can see, we have another value which will give us the value of the function x equal to 0. Therefore, when f of x is equal to 0, it is given that 2.5 is our root. So therefore, for this problem, the roots now are negative 1 and 2. So we can check our answers by your factoring or by your quadratic formula or quadratic equation. You will also get negative 1 and 2. Okay, next example, number 2. Find the root of the equation. Function of x is equal to 2.5 x squared minus 6.25x equal to negative 3.9. So we'll be using a delta or an increment of 0.5. So for our solution, let's have x sub o, our initial guess at 0. Substituting now 0 in our equation, we get 3.9. So increment of 5, so 0 plus 0.5 will give us 0.5. Substitute this in our equation, we'll now have 0.5 times 0.5 squared minus 6.25 times 0.5 plus 3.9, which will give us a value of 1.4. Okay, so walang equal to 0, walang change in sign, so we continue with our increment. So 0.5 plus 0.5, that's 1. Substitute this in our equation, we'll arrive at 0.15. So again, no equal to 0, no change in the sign, so we move on to 3. So that's 1.5, which will give us 0.15 as well. So, pag tinuloy natin ito, ang magiging values ko will all be positive. Okay? So, walang change in sign. Wala ding mag-equal to 0 in this increment. So, what we will do is, since we have here two values that would give us the same value, we will be starting off here. So, kung wala tayong makukuhang negative or walang magiging change in the sign convention. Okay? So, in that case, there's no change of sign in our values. So, we will now be using the two values of x in which the function of x will have the same result. So, we'll be assuming now that the root is found between 1 and 1.5. Okay? So in this, we'll now be repeating our process and we'll be changing our increment. Instead of 0.5, maybe we could use 0.05. So in here, you can have the option of what increment you're going to use. Okay? So let's start again. from a range 1 to 1.5, and we'll be using an increment of 0.1. So we'll have x equal to 1. We're able to compute it at 0.15. So x 1.1 will now be 0.05. X is equal to 1.2, which will give us 0. And then we have 1.3, which is equal to 0 as well. So nag-0 yung ating equation, function of x. Therefore, the roots now for the given equation 2.5x squared minus 6.25x equal to negative 3.9 are 1.2 and 1.3. Okay? So next example, the first root of, so determine the first root of the equation 4.15x squared minus 16x squared plus x or plus 8 equal to 0. Using now incremental search, use an initial x sub o equal to 0 and a delta equal to 0.1. So we have to perform 3 iterations for this for the best approximation. So kung hindi binigay kung ilang iterations, you can do as many as you want in order to have more iterations, more accurate answer. Okay? So let's start. So for our solution, we will need x sub n. And our x sub n, we substitute in our equation to be able to get f of x. So our initial is 0. Substitute in our equation 4.5 times 0 squared minus 16 times 0 plus 8. This will give us a value of 8. So increment of 1, so 0 plus 1, 0.1. Substitute this in our equation. That's 4.15 times 0.1 squared minus 16 times 0.1 plus 8 will give us 6.442. So walang change in sign, walang nag-0. So let's continue. 0.1 plus delta, so this 0.2. Substituting this in our equation, we'll now get 4.966. Again, increase this, 0.3. Substitute, we arrive at 3.574. So we continue, 0.3 plus delta is 0.4. Substitute, we get a value of 2.2265. Then, next x is 0.5. Substitute, we get now 1.038. Then, next, we have 0.6. Substitute, we get now negative 0.105. Ayun, nagkaroon ng change in sign. So, meaning, for our first iteration, there was a change of sign. So, we could say that the root now of, or the first root of our given equation is at 0.5 plus 0.6 divided by 2, or that is equal to 0.55. Pero again, we are required to have 3 iterations to have a more accurate value or solution. So we move on to our second iteration using now our 0.5 and 0.6. So from 0.5 to 0.6, let's change our iteration. Let's have a smaller iteration or interval of 0.02. So we have 0.05. So we get now, substituting this, we get 1.038. So 0.5 plus 0.02, 0.52 will give us now 0.0802. So 0.52 plus 0.02 is 0.54, will give us 0.57. Next, we have 0.56. Substituting, we will get 0.341. And then next, 0.58. Substituting this in 4.15x squared minus 16x squared plus 8 is 0.116. And then for 0.6, we get negative 1.06. So again, there's a change in sign. So meaning, So from 0.5 to 0.6, ngayon sa second iteration natin, we were able to minimize again the interval of our unknowns or the limits of our root. So for the second iteration, the root now can be estimated at 0.58 plus 0.6 divided by 2. So XR now is equal to 0.59. Okay, so second iteration pa lang to, so we move to our third iteration, and the third iteration now will come from 0.58 to 0.6. So let's have a new delta. So instead of 0.02, let's make it at 0.002. So our value now will be 0.58, 0.582, 0.584, 0.586, 0.588, 0.59. So substituting all these values of our x, we now arrive for 58, we get 0.116. For 582, we get 0.094. 584 will give us 0.071. 586 will give us 0.049. 588 will give us 0.027. Then we have 0.590 is 0.005. So wala pa ring change in sign, wala ding nag-0. So dagdagan natin, we have 0.592, which will give us negative 0.01. So there's a change in sign convention. So therefore, we now have a smaller range of our limit for our root. And for the third iteration, we can now estimate our root at 0.59 plus 0.592 divided by 2, or we have now a value of 0.591. So this is our root of, or the first root of the equation 4.15x squared minus 16x squared plus 8 equal to 0. So if you want a more accurate answer, you can continue to the fourth iteration or fifth iteration. So as you can observe, more iterations, more accurate answer, or mas maliit na delta, pag 0.01 yung ginamit natin dito, mas makikita agad natin kung ano yung ating, or mas magiging maliit yung values ng ating mga estimated XR. So you can have this as your practice. What will happen if I will use another value of delta in our solution? So basically, you are going to solve that way. You'll be arriving as well at approximately or nearly 0.59. Okay, so that's it for part 1 of Module 5 for the first method of solutions for the roots of nonlinear equations. Thank you for listening.